In this set of practice questions, you're asked to reflect on what has changed from one question to the next, how this affects what you think the answer might be, whether it's bigger, smaller, the same, how many answers there will be, and then we're going to use a formal method to check. So first of all, we're going to solve this quadratic x squared minus 5x plus 6 is equal to 0. We can factorize that into x minus 2, x minus 3 is equal to 0, which means x is equal to 2 and x is equal to 3. In the next equation, we see that the 5 and 6 have stayed the same. What has changed is x has become an x squared and x squared has become an x to the 4. How do you think this would affect the answers? So using the method we saw before, we're going to let t equal x squared, which gives us the equation t squared minus 5t plus 6 equals 0. Now that is exactly the same as we had above, which means that t is equal to 2 or t is equal to 3. But t is not what we want x, so we need to solve to find x. T is equal to x squared, so x squared is equal to 2, means we have x is equal to plus or minus root 2. And x squared is equal to 3, means we get x is equal to plus or minus root 3. Now let's look at the next question. The only thing that has changed is the squared has become a linear. Let's try this. If t is equal to x, then we just get the same thing in t, which we can't solve. If t is equal to x squared, we can't replace this one. Actually, this method does not work. We can't solve this. It is not a hidden quadratic. This particular question is here to identify that not all three-term equations are hidden quadratics. You have to have the structure where this variable is the square of this variable for it to work. Let's move on to the next one. Going from 2 to 4, now instead of squared we have cubed, and instead of to the 4 we have 6. The x to the 6 is the x cubed squared. We can use the hidden quadratic method here. How many solutions do you think there are going to be? Let's solve it now. We're going to say t is equal to x cubed, which means we get to t squared minus 5t plus 6 is equal to 0. So t is equal to 2, t is equal to 3 again. From there, that means x cubed is equal to 2. So x is equal to the cube root of 2. Or x is equal to the cube root, missed my equal sign there, the cube root of 3. And this time there are only two solutions, because when we cube root, we don't have the plus minus. Question 5, this time t is going to be equal to x to the power of 4. What do you think is going to happen in terms of the number of solutions? Without writing out all the steps, we know that t is going to be equal to 2, and t is going to be equal to 3 again, because we're going to get the same equation, which means x to the 4 is equal to 2, which means that x is equal to plus or minus the 4th root of 2, and x is equal to plus or minus the 4th root of 3. Moving on to question 6. Now we've got x and root x. How might that affect how many answers there are? What do you think the answers might be before we work this out? So this time t is equal to root x. We're still going to get the same equation, which means t is equal to 2, t is equal to 3, which means root x is equal to 2. Now if root x is equal to 2, we need to square this time, so x is equal to 4. If root x is equal to 3, then x is equal to 9. If this is x to the half and x to the quarter, t is going to be x to the power of 1/4. Again, as always, t is going to be 2 and t is equal to 3 for these examples, because we get to the same equation every time. Which means that this time x to the quarter is equal to 2. So x is going to be equal to 2 to the power of 4. 2 to the power of 4 is 16. And x is equal to, well, this is x to the quarter is 3, so x is equal to 3 to the power of 4. 3 to the power of 4 is 81. Now we get on to some slightly more complicated ones, which are not just polynomials of x. But this still has the same structure. What has changed is instead of x to a power, it is x plus 1 to a power. So this time t is going to be x plus 1. We still have t is equal to 2 and t is equal to 3 when we solve the resulting equation, which is t squared minus 5t plus 6 equals 0. But if x plus 1 is equal to 2, then x is equal to 1. If x plus 1 is equal to 3, then x is equal to 2. So we get two solutions again, 1 and 2. In this one, we have to combine two things. T is going to be equal to 2x plus 1 squared, this variable here. As always, t is going to be 2 and t is going to be 3. When t is equal to 2, we get 2x plus 1 squared is equal to 2. That's a quadratic equation in itself that we're going to have to solve. When we solve that, we get x is equal to minus 1 plus or minus root 2 over 2. We also have the possibility that 2x plus 1 squared is equal to 3. That's the solution when t is equal to 3. In that case, x is equal to minus 1 plus or minus root 3 over 2. So we get 4 solutions, all of which are surds this time. X to the 2/3 and x to the third means t is going to be x to the third. That means x is going to be 2 cubed, which is 8, or x is going to be 3 cubed, which is 27. Now this one is a little bit more difficult to spot, but the key here is the fact that 2 to the 2x is actually 2 to the x squared using laws of indices. That means t is equal to 2 to the x, because this is the variable and this is the variable squared. It boils down to the same equation, t squared minus 5t plus 6. So t is either equal to 2 or t is equal to 3, which means 2 to the x is equal to 2, or 2 to the x is equal to 3. If 2 to the x is equal to 2, then x is equal to 1. If 2 to the x is equal to 3, then x is equal to log base 2 of 3. And finally, log 2x squared minus 5 log 2x plus 6. In this case, t is equal to log 2x, the variable and the variable squared being here. As always, these are going to be equal to 2 and 3. When log 2x is equal to 2, this is saying 10 to the power of 2 is equal to 2x, which gives us that x is equal to 50. 100 is 2x, so x is 50. The second answer would be when log 2x is equal to 3, means that 10 cubed is equal to 2x, and therefore x is equal to 500. Now you should have noticed through those 12 questions, bar question 3, they all had the same structure. They all boiled down to t squared minus 5t plus 6 equals 0. But those last steps we had to do when we did the substitution at the end gave us very, very different answers. But this series of questions shows you that lots of different questions, what look like very different equations, actually have the same structure underneath them. And these hidden quadratics are something you should be looking out for.